I want you to picture something for a moment. Imagine you're standing on the bank of a river. But not today. Imagine you're an ancient observer, maybe a Greek philosopher or an Egyptian priest.
Right, centuries ago.
You stand there for years, you watch the seasons change, you see salmon fighting their way upstream to spawn, you see frogs, you see their eggs, you get it, you understand how life works.
Parents make babies, babies grow up. The basic cycle.
Exactly. But there's this one creature in that river that just refuses to play by the rules. The eel.
It's the biological equivalent of a locked room mystery. If you were that ancient observer, you'd see adult eels everywhere. They were a staple food source.
Oh, for sure.
You'd see thousands of them. But in all your years of watching, you would never ever see an eel egg. You'd never see a baby eel.
And here's the kicker. If you cut one open for dinner looking for roe or milt.
Nothing.
Yeah.
Not a single reproductive organ. It's like they were just there.
That is the part that just blows my mind. To the ancient world, the eel was effectively a ghost. It existed, you could eat it, but it had no origin story, it just appeared.
And that impossibility is where we're starting, because for thousands of years, the prevailing theory wasn't biology, it was basically magic. People genuinely believed these things just spontaneously generated from mud.
Because the alternative, that they were coming from somewhere completely invisible, was just too hard to grasp.
Which brings us to today. We finally know the truth, but honestly, the scientific reality is far, far stranger than any magic the ancients could have invented.
Welcome, listeners, to another My Mind MashUps deep dive, where we unravel mysteries, spark curiosity, and make sense of complex ideas together.
Today, we are tackling the Sargasso secret. We are looking at the European and American eel, creatures that migrate thousands of miles to a place without coastlines to do something no human has ever filmed.
It's a story about invisible journeys, an internal magnetic GPS, and why science sometimes looks a whole lot like a detective novel.
It really does.
Don't forget to like, share, and subscribe if you enjoy content that makes you think. Okay, let's unpack this. We have to start with the history, because the theories people came up with are just absolutely wild.
They really are. But you have to have some sympathy for them. They were working with the information they had.
Okay, fair enough.
So take the Egyptians. They were convinced eels rose from the Nile specifically because of the sun's heat. Like the warmth itself just baked life into the river slime.
Spontaneous generation, right? Life just popping out of non-living matter.
Exactly. And then you have Aristotle, the guy who basically invented the classification of animals.
The father of logic himself.
And he was completely defeated by the eel.
He was a meticulous observer, wasn't he? I mean, he dissected everything.
He did. He looked for sex organs, gonads in eels, and found absolutely nothing. And because he couldn't find a male or a female, he concluded they must emerge from, and this is a quote, the entrails of the earth.
Entrails of the earth.
He basically thought they were like super advanced earthworms that just mutated into fish.
That sounds like a metal band name waiting to happen. But it didn't stop there, right? Pliny the Elder had a theory too.
Oh yes. Pliny suggested that baby eels were formed from skin particles.
From skin?
Yeah, skin scraped off adult eels when they rubbed against rocks.
Wow.
That was the best logic they had. If they don't have eggs, maybe they reproduce like a rash. But here's where it gets really interesting. Scientifically, they weren't just bad at looking. The eel's own biology was actively hiding the truth.
How so?
Early naturalists couldn't find gonads because eels simply don't have them for the vast majority of their lives.
Wait, so if I catch an eel in a river today, it's, what, genderless?
Precisely. Sexually undifferentiated. They don't develop those organs until the very, very end of their lives when they're far out at sea and, basically on their deathbed.
So Aristotle was looking for something that literally didn't exist yet.
He was. And it wasn't just the organs. The actual physical form of the eel changes so much.
Right, the different life stages. Early scientists thought they were completely different species.
Exactly. The life cycle is so complex, the term is catadromous, which means they live in fresh water but go to the ocean to spawn. The specifics, though? They're like something out of a sci-fi movie.
So let's trace that journey. It all starts in one place, right? The Sargasso Sea.
The Sargasso.
Yeah.
It's this vast gyre in the North Atlantic, east of Bermuda. And it's unique because it's a sea with no coastline.
No land at all.
None. It's defined only by 4 rotating ocean currents that just trap water in the middle. It's deep, hundreds of meters, and the surface is choked with this floating sargassum weed. And this is the only place on Earth where these eels spawn.
So the eggs hatch in this deep, open ocean. And what comes out isn't a tiny eel, it's a What's the term again?
Leptocephalus.
Leptocephalus.
And if you saw one, you would not think fish. You'd think transparent ribbon. They're flat, they're leaf-shaped, and they're filled with this kind of jelly-like substance.
I was looking at the description, and there's this one detail that just stunned me. They have no red blood cells.
None. And that's a crucial adaptation. Red blood cells are red because of hemoglobin, which carries oxygen.
But color makes you visible to predators.
Right. So by not having red blood cells, these larvae stay completely transparent, almost invisible in the water.
How do they breathe?
Straight through their skin.
Yeah.
Their body is so thin and flat that oxygen can just diffuse directly from the seawater into their tissues. No need for a complex circulatory system yet. They're just drifting, transparent ghosts.
That is wild. And they're eating something called marine snow, which sounds pretty, but it isn't, is it?
It's essentially the detritus of the ocean. Dead plankton, organic goo that drifts down from the surface.
So they're invisible, breathing through their skin and eating ocean dust bunnies.
Pretty much.
Yeah.
And they drift like this for 9 to 12 months, just riding the currents toward Europe or North America.
A full year of just drifting. Then they hit the continental shelf and the transformation starts.
Yes. This is the first metamorphosis. They shrink in width and become glass eels. Still transparent, but now they have that classic cylindrical eel shape.
Glass eels? That sounds almost beautiful.
It is. But then they hit the freshwater, they move into rivers, lakes, and they gain pigment, turning that yellow-green color. Now they're elvers and then yellow eels.
And this is the stage most people would recognize.
Right. This is when they live in our rivers, hiding in the mud for anywhere from 2 to 25 years.
25 years? That's a huge chunk of time to just hang out in a river.
It is. They're just growing, eating, waiting, but then some kind of trigger goes off. We still don't fully understand it, maybe fat reserves, maybe temperature, but they decide it's time to go home.
And this is the silver eel phase.
Yeah.
This is the part of the story that turns into a body horror movie for me.
It really does. It's a one-way ticket. Their skin turns dark on top and silvery on the bottom for camouflage in the deep ocean. Their eyes get huge, like massively enlarged to see in the dark.
But the internal part is the most shocking. Their digestive tract, it degenerates.
It does. It dissolves. The gut atrophies. They stop eating entirely. Their body literally breaks down its own digestive system to make room for the reproductive organs, the gonads, that are finally developing.
I had to read that twice. Their stomach just dissolves.
Gone. So they are fueling a swim that could be 4,000 miles long, purely on stored fat.
An extreme endurance run with no refueling stations.
Exactly. If they run out of energy before they get there, they just die. They spend decades waiting just to dissolve their own stomachs and swim to their death to keep the cycle going.
It's just so intense, and it really puts the whole mystery in perspective.
It's a life cycle of extreme endurance and total sacrifice.
If this is resonating, hit that subscribe button so you don't miss the next deep dive. Like, comment, and subscribe to hear more My Mind MashUps deep dives.
It really does highlight how little we knew for so long.
Which brings us to the detective story. Because we've laid out this incredible journey, Sargasso to river and back. But here's the eel in the room. If they spawn in the deep ocean and nobody has ever seen it happen, how do we actually know any of this?
That is the million-dollar question. For a long time we didn't, but in the early 1900s, a Danish scientist named Johannes Schmidt decided he was going to solve this. And his dedication was, well, borderline obsessive.
He didn't have GPS or submersibles, just a boat and a net.
And 20 years of patience. Starting around 1904, he sailed across the Atlantic, just dragging these fine mesh nets through the water. He was playing a game of hot or cold on an oceanic scale.
The logic being the smaller the larvae, the closer he must be to the nursery.
Exactly, like following a trail of breadcrumbs. Off the coast of Europe, the larvae were inches long. Mid-Atlantic, they were smaller. Finally, in the Sargasso Sea, he found these tiny newly hatched larvae, just millimeters long.
That was the smoking gun.
It was. He concluded the spawning site had to be there. But that was over 100 years ago. And finding larvae is one thing, tracking the adults is another.
Right, because the adults just disappear into the deep ocean. It's a black box.
It was a black box.
Yeah.
But this is where modern tech changed the game. The source material highlights a major breakthrough around 2018 using satellite tagging.
How do you even tag an eel for that kind of journey? They're slippery.
It wasn't easy. Scientists tagged 26 female European eels with these pop-up satellite tags. The idea is the tag records data depth, temperature, location, and then after a while it pops off, floats to the surface, and beams everything to a satellite.
And did they make it?
Most didn't. Many were eaten, some tags just failed. But 5 of them were tracked all the way to the Sargasso Sea.
Wow.
A journey of between 3,000 and 6,000 miles. It was the first direct proof that these eels were traveling to that exact spot Schmidt identified a century ago.
Okay, so we know where they go, but how? How does a tiny glass eel or dying silver eel navigate a featureless ocean?
Magnetic fields. This is one of the coolest findings. A 2017 study showed that eels have an internal GPS.
An internal GPS, like they can feel the North Pole or something?
Basically, yes. They are sensitive to the Earth's magnetic field. In lab experiments, they put these tiny elvers in a magnetic coil system and simulated the magnetic fields of different parts of the Atlantic.
So they tricked the eels into thinking they were somewhere else.
Exactly. And in every single case, the eels oriented themselves toward the Gulf Stream. If the magnetic field said, "You're south of the stream," they swam northwest. If it said, "You're north," they swam southwest.
That is incredible. They are reading the magnetic signature of the planet to catch the currents home.
They are. But despite all this, the tags, the magnetic studies, you still see people online claiming science doesn't know where eels come from. Why does that myth persist?
It's that pics or it didn't happen culture, right?
It's a classic case of confusing seeing with knowing. In our visual culture, if there isn't a 4K video of it, people assume it's still a total mystery.
Right. We want the footage of the actual moment.
And we just don't have it. But think about the logistics. They spawn at depths of hundreds, maybe 1,000 meters. The spawning zone is 2,000 kilometers wide. The eggs are tiny. There are no nests.
It's like trying to find a specific needle in a haystack, but the haystack is the size of a continent, pitch black, and underwater.
Precisely. The expert rebuttal here is that we haven't filmed deep-sea squid mating either. But we don't claim they magically appear. We have robust indirect evidence. The genetics, the larval distribution, the tracking, we know they spawn there. We just haven't been invited to the wedding.
I like that, haven't been invited to the wedding. But there's a much darker side to this. We might know where they come from, but we are rapidly losing them.
And this is the ecological reality check. It's grim. The European eel population has declined by over 90% since the 1980s.
90%.
They're critically endangered. American eels are down by about 72%.
That's a population collapse. What's driving it?
It's death by 1,000 cuts. First, physical barriers. We've dammed up so many rivers for hydropower. The young eels literally cannot swim upstream. It's like putting a brick wall on a highway.
And when the adults try to swim back down to the ocean,
They get chopped up by turbines. It's horrifying.
Yeah.
Then you have pollution, habitat loss, and illegal fishing. There's a massive black market for glass eels.
Really?
They're sometimes called the cocaine of the sea because they're so valuable, especially for food markets in Asia.
And I imagine climate change plays a role.
It's the silent killer. Remember how they rely on currents like the Gulf Stream? If those currents shift or weaken, the larvae might just drift off course, starve in the open ocean before they ever reach home.
So why should we care? I mean, beyond the idea that extinction is just bad, what do eels actually do?
They're crucial connectors. They transport marine nutrients into freshwater ecosystems. They feed birds, fish, mammals. But there's one specific connection that's incredible: the freshwater mussel.
Mussels, the shellfish.
Yes. Mussels are the kidneys of our rivers. They filter the water and keep it clean, but they can't move. To reproduce, they need a way to spread their babies upstream.
Let me guess. The eel is the bus.
The eel is the bus. The mussel larvae clamp onto the gills of an eel, hitch a ride upstream, and then drop off to start a new colony. If the eels disappear, the mussels can't reproduce. If the mussels disappear, the water quality crashes.
It's a domino effect. Losing the eel means dirtier rivers and a collapsing food web.
Exactly. It's not just about losing one slippery fish.
So where does this all leave us? We've gone from ancient myths about mud and sun to Aristotle's earth entrails, all the way to satellite tracking and magnetic navigation.
We've moved from myth to data. The eel isn't a magical anomaly. It's a biological marvel that connects the deep abyss of the Atlantic to the smallest creek in your backyard.
And I think that brings us to our final provocative thought for this deep dive.
The eel really teaches us a lesson about humility. In a world of information overload, we so often confuse the unseen with the unknown. We think if we can't see it, it isn't real.
But the eel proves that life finds a way in the dark depths, far from our cameras.
So the mystery now isn't where they go, we know that. The real mystery is whether we can save them before they disappear for good, not into the mud, but into extinction.
That is a heavy but necessary place to leave it. The unseen is not the unknown.
Exactly. And sometimes the things we can't see are the most important things of all.
Thank you for listening. Find My Mind Mashups everywhere you listen. Amazon Music, Audible, Facebook, Pocket Casts, Spotify, TikTok, and YouTube.
And we do want to hear from you. Do you think the mystery of the eel helps or hurts its conservation? Does the fact that we can't see them spawning make us care less?
Drop your thoughts in the comments. Your perspective could shape our next deep dive. Until next time.